We're here today at the Kellogg wastewater treatment plant to do a little test run on our 4NT sewage bypass system, the Series 1 sewage bypass system. We're basically backed it up, this is the Willamette River, and backed it up to the edge here, and we're going to be pulling about a 20-foot suction lift out of the river and just discharging right here. It'll run back down. Let's take a look at the distance here.
You want to throw a tape on that, Chris?
There's the suction line. So we're looking at about 20 feet here. Actually, Don Carlisle is making sure of the depth here, or the lift.
We're working about a 21-foot suction lift.
21 foot, so we were pretty close there.
That's the horizontal run.
Right.
The controls that we're using is basically two functions. One, power failure, and the other one being high wet well level. This thing is brought out, put in its mooring site, and hooked up to 110 volt coming off of the pump station. As soon as there's any power interruption, this pump station will actually fire up, start, and run at an idle speed until the upper level sensor's tipped. Once the upper level sensor's tipped, it will accelerate to a preset RPM based on the tachometer, based on system head design and so on. Once the liquid level is evacuated and we come back down to the bottom level sensor, the system will back to an idle and basically does two things. Eliminates excess wear on the seal and eliminates excess fuel consumption. We have a test feature on all the lamps for power failure, wet well floats, oil pressure, coolant temperature, over crank, and over speed. And these are all incorporated in the control panel. It has a HOA or hand-off automatic, and the engine speed adjustments either increase or decrease to the preset RPM that I was talking about. I'm going to drop the water in the suction pipe here so we have a complete dry prime condition, and we'll just see how long it takes at a given RPM, about 1700 RPM for it to physically prime 21.
And while Don's doing that, I'll talk a little bit about how the Ready Prime works. We essentially have a non-clog pump here. We can use any of our non-clogs in the Ready Prime configuration. This chamber that's right here is the suction float chamber or separation chamber, and basically we have a float ball in there. When the pump primes, that ball will float up to the top and seal off a valve, which in turn seals the airway to the diaphragm pump. The diaphragm pump is the pump that is actually drawing the air out of the suction line and bringing the media up to the pump for priming. Now this tank here in the center, the square tank, is an oil chamber, and that is used for a run dry feature. The run dry feature enables the pump to run in a dry state, such as when it's priming, and not burn the seal up. And this can the pump can run for 8 hours or better without having any fluid in the pump. Now the enclosure itself is a sound attenuated enclosure, 75 decibels up to 100 feet. Another feature of the trailer, which you see here, is what we call a mooring option. And you notice the jack stands at the corners of the trailer. If we were to use this station in a sewage bypass situation where you leave it for days or weeks, we would basically use the jack stands and separate the trailer from the skid. If you lift it up far enough, the trailer can be backed out and then the skid lowered down directly onto a pad. This is a safety feature that we incorporated in this unit. Fire this baby up now. We're going on a manual start. This would be a typical dry prime situation. In other words, there's no water in the suction line at all. Don's going to click it on. You can hear the diaphragm pump kick on, and right now it's evacuating all the air out of the suction line. Depending on lift and RPM of your motor will depend on how fast the priming takes place. About 1750 RPM. We have an adjustable RPM feature on this control unit. The Don's going to bring the RPM down, which in turn is going to decrease the flow and the pressure. So it's fully adjustable to suit the needs of your pumping requirements.
System head design and so on.
You see, what RPM's that at, Don?
That's about 780.
About 780, so we went from 1700 down to 780. You can see the difference. One other thing about this unit, it runs off of propane. These Cummins engines, and the ones that are available for the sewage bypass are propane or natural gas. You can get diesel engines. You can see from back here maybe better how the mooring feature would work. If we crank the jacks up a little higher, that whole skid unit would come right off the trailer, and we could pull the trailer out from under it and set it back down. These two hoses coming down here, that's the other side of the oil reservoir for the run dry option, going into the back plate of the pump to lubricate the cyclo seal. Don's a step ahead of me here, or a step behind me. So what we're going to demonstrate right now is a condition where we may start to lose prime somehow. So what Don's going to do is basically disconnect partially the suction pipe to allow air into the suction of the pump. What will happen is the float will drop back down and allow the diaphragm pump to kick in and start to reprime the pump. Let's listen and see if we can hear it happen. So now we're losing prime. We don't have as much water coming out of our discharge. We hear the diaphragm pump. Now we've totally lost prime of the pump. Now because we're running at a slow RPM, it would take a while for this to reprime, so Don's going to increase the RPM.
Increase the RPM. Here's the vacuum pump become quiet, comes under hydraulic load pump.
Now we're back to pumping.
Now you don't hear the vacuum pump.
Again, here's our suction lift that we calculated to be about 21 feet coming up through this hole in the seawall into the pump.